Hi, we are now in the second subtopic of chapter 3, which is binomial expansion. But before that, we introduce you n factorial. So for any positive integer n, we define n factorial as n times n minus 1 times up to times 1. So it means here, we have to start with n according to our factorial and ends with 1. So look at n plus 1 factorial. As previously, we have to start with n plus 1 and then multiply by the term minus 1 from the previous term, which is n, times n minus 1 up till 1. We can also write this in the form of n plus 1 times n factorial. Next is the binomial coefficient. We can write it in the form of this one, which also means NCR equals to n factorial divided by n minus r factorial times r factorial. So now we will look at the binomial expansion. For any positive integer n, we have the following expansion. With a and b given, we start with nc0 a to power n times b to power 0, and doing so up till ncn times a to power 0 times b to power n. Now, look at example 19. We have to evaluate 5 factorial here. So, as stated previously, we have to start with 5 itself and then times the term minus 1 from the previous term up till 1 as follows to get 120. For D, we have 5C2 with n equals to 5 and r equals to 2. Substituting this n and r into the formula of the binomial coefficient, we have the following, and simplify it, we will get 10. And we are done. Now, example 20, we have to expand the following by using binomial expansion. We can see here that our n is a positive integer. So we have n equals to 4 with a equals to 1 and our b equals to minus 2x. We then need to substitute all these three numbers into our binomial expansion formula to get the following. And then we have to carefully calculate each term as follows. Carefully calculate it means, so for example, I take the third term here. We have 4c2 equals to 6, 1 squared equals to 1, and then for the term in the bracket, you have to expand minus 2 to power 2, which is 4, and then x to power 2, which is x squared. Now calculating each coefficient carefully again, we'll get 1 minus 8x plus 24x squared minus 32x cubed plus 16x to power 4. Next, example 21. We first have to expand the following expression in ascending power of x and hence to find 1.02 to power 5 up to 4 significant figures. Now, we have n equals to 5 with a equals to 2x and b equals to 1. Similarly, as in previous example, we have to substitute our n, a, and b into our expansion formula to get the following expansion. Then, carefully calculate each term to get the following expansion. But note that the question asks for ascending power of x, so we need to rearrange the answer in ascending order of expansion. Now, we have to find 1.02 to power 5 from our binomial expansion. To do so, we have first to separate 1.02 into two terms as follows. 1 plus 2 times 0.01. We do this in order to compare with our previous binomial expansion, as this one. And note that our x here is 0.01. With this x, we then substitute into our binomial expansion that we found earlier to get the following. And then calculating it, we will get 1.02 to the power 5 equals to 1.104, correct to 4 significant figures. And we're done.